Tenkata is the manufacturer of the Geolon range of geosynthetics. The Geolon geosynthetics are produced out of several kinds of materials, like polyethylene, polypropylene, and polyester yarns. Especially for the marine engineering projects, the polyethylene and polypropylene geosynthetics are used. The geosynthetics are used for facine mattresses as a filter construction or geosystems for cores of dikes and underwater berms. To prevent damaging to the fabric when they are hit by rocks, a layer of reet is put on top of the geosynthetic. In this case, a polypropylene geosynthetic is used to prevent erosion of the new dike. By connecting facines to the fabric, the rock will not roll off the fabric. Therefore, loops are weaved into the fabric. The facines are knotted to the geosynthetic on shore. After that, with a tugboat, the mattress will be put in position. Eventually, by dumping rock on top of the mattress will sink to the bottom of the sea. Finally, the dike is completed and some land reclamation is built up. Another solution is to make a profile of the dike and pull with a crane a sheet of polypropylene geosynthetic over the profiled dike. By seaming several sheets of geosynthetics with each other in the factory, the prefabricated panel can be installed. First, a layer of small particle granular fill is placed on top of the fabric. After that, the armor layer is put on top of the granular layer. The manufacturing of the facine mattresses is a labor job with a lot of handwork. In the geosynthetics are loops woven in to make it possible to connect the facines. The layer of reet is for preventing damaging by placing the rock fill. If the mattress is finished, it can be pulled off the shore and floated into position. By connecting a lifting beam to the facine mattress can be pulled over the top of the dike. In this special case, high forces will occur in the geosynthetic, so the need of a high-strength geosynthetic is necessary. After that, the armor protection is installed to finish the dike. This part shows the application of geotubes for the core of a dam for a silt depot in a lake. The bottom is covered with a geosynthetic mattress. The geotubes are placed on this bottom mat. A geotube is a prefabricated sausage-shaped piece of geosynthetic and can be filled at the top. After installing the 3 geotubes, a geosynthetic top mat is applied and finished with rock fill. The 25 meters wide bottom mattress is carefully installed using a winch-operated pontoon. The sand needed for the fill of the geotubes may be obtained nearby by using a dredger. The used sand should be suitable for filling the geotubes, therefore it is important to know the grain size. Sand is dumped into barges and shipped to the silt depot. The sand is discharged into a hopper and a certain amount of water is added. The mixture of sand and water is pumped into a floating pipeline which is connected with the first inlet of a geotube. The filling process of the geotube is now started. During filling, the geotube is regularly inspected visually. The volume of the sand-water mixture pumped into the geotube under pressure is many times larger than the actual contents of the geotube. However, the geosynthetic is permeable as sandtight. The water is squeezed out and the sand stays behind. As soon as the stone basket at the inlet is full, the process will stop. The inlet is disconnected and the stone basket will be emptied. This is done at regular intervals. Now the pontoon is shifted to position the filling spout at the next inlet of the geotube. When the filling spout is connected again, the pumping process is resumed and the next part of the geotube is filled. When the geotube is completely filled through all the inlets, the next geotube is supplied, positioned and filled. A special designed catamaran is used to deploy the top geosynthetic over the geotubes. When the top geosynthetic is installed, the rock fill will be placed to finish the dam. The result? A strong dam for a silt depot, built with naturally available materials in the lake. This part shows the building of a dam in 15 meters deep water with geocontainers. In short, how the dam is made. A geocontainer filled with sand is dumped out of a split barge. On the outsides of the dam, 2 geocontainers are dumped next to each other. Sand is filled between the 2 outer rows of geocontainers. Other layers with geocontainers are stacked on top of the other geocontainer and sand is filled between. At the top of the dam, geotubes are installed because of the decreasing water depth. A good stable dam is made with steep slopes underwater. A geocontainer is a prefabricated piece of geosynthetic and rolled on a steel pipe. The geocontainer is unrolled in the split barge. The barge should have no sharp edges where you could damage the geocontainer. The geocontainer is folded in the factory and is now deployed in the split barge. The cover of the geocontainer must be pulled over the sides of the split barge. The sizes of the geocontainer are exactly made for the given split barge. This one has a capacity of 300 cubic meters. The geocontainer should be filled with sand or small granular fill material to a capacity of 80% of the barge. During filling, the geocontainer should not be hit by the crane, so damage will not be caused to the geosynthetic. A special air ventilation opening prevents the geocontainer from collapsing by overpressure during the dumping operation. The geocontainer is sand-tight closed with a handset sewing machine. For the rope closure, which withstands high forces during the impact in the bottom, every 30 centimeters a rope has to be pushed through the fabric. This rope will be knotted with a double knot. A last visual inspection is made to see if everything is under control. The split barge will be opened and a large sand container is dumped on the bottom. With this system, you can make dams and underwater berm. Also, it is possible to fill scour holes. If you have some more technical questions about the geosynthetics and geosystems, please don't hesitate to ask the technical department. Ten Carter Nicolon, the world leader in geosystems.